even though most of us here were taught that was impolite when we were young. Anyway, so the bottom line is that's full duplex. Well, it doesn't work that way on radio on simplex, right? You can only be transmitting, talking. Everybody else got to be listening to you. Then you unkey the mic. You say, "Go ahead, Mike, over to you," and then Mike talks. That would be simplex. Okay. Well, the same methodology applies here for repeaters or antennas, or for that matter, base stations. If you wish to simultaneously transmit and receive through the same what? Antenna. Okay. What's the big deal? Okay. Well. So yeah. So these duplexers allow duplex operation. Allow us to simultaneously transmit and receive at the same time through one antenna, one feed line. Okay. Now, not on the same channel, right? On the same frequency, because it'd be colliding, right? So the first thing you have to have is you have an input and an output frequency, or a receive and a transmit frequency. And these are what make that possible through a single antenna and a single feed line for us to transmit on one frequency while we're receiving on another. And even today, a lot of people, even some, quite honestly, veteran hams I will listen to will talk, and they don't quite get that concept that when they key their microphone. If you look at most people's displays in your radio, what happens to when you key your microphone? What happens to the displayed frequency?
Goes to the transmit frequency.
Yeah, it goes to the transmit frequency, right? It's no longer showing 146.970. Now it's showing 146.370, right? And that's because when you transmit from your mobile, you're transmitting at that frequency. The repeater is receiving on that. And then when you unkey the repeater, of course you hear it transmit back to you on the output frequency, or the 970. And these are the piece of equipment, duplexers or cavities, that allow you to do that. Now, the handout I'm going to give you in a minute, and we're just going to go through it briefly once we all sit back down for a minute, really does a great job of explaining this and how this occurs. But the key thing you need to keep in mind is that there is a separation there has to be between those transmit and receive frequencies. Turns out in the ham radio bands, we have a pretty narrow what's called spacing between that transmit and receive frequency. It's only, to be honest, it's only 600 kilohertz. You go to the commercial side, and it's usually a megahertz, which is almost double that, or even more. A lot of bands it's 1.5 megahertz. So there's even a farther spacing between those frequencies, which makes it a little easier to get rid of the interaction. What the duplexers do is allow you to do that simultaneously without interfering one or the other. And they do it by tuned circuits. But if you looked inside here, you'd be amazed at how simple these are made. This is basically a threaded rod from the bottom to the top with a coil, like what's the best way, like a fan blade device almost, a coil that sits in there and makes contact with the sides of the cavity as it's spun up and down. And basically you're just changing the electrical length of each of these cavities to match the frequencies that you either want to stop, or as we say in terminology in the radio industry, notch, or pass. Notch or pass. Because you want the receive frequency to come in one way into these things, and you want your transmit frequency to go out the other, and you don't want the two to interfere with each other. So duplexers are pretty amazing in that regard of what they do. Just so you know, for reference, a new pair like this would cost right now about $1,800 new. And it's not that they're so sophisticated to make, it's that there's not a lot of them made. Now, if you don't have duplexers, how can you use a single feed line and antenna to do the job of both simultaneously transmitting and receiving? The answer is you can't. That's what the magic of these is. What's the alternative, though, if we want to put a repeater on without duplexers? Can anybody tell me that? How else could we make that repeater work? Two antennas.
Right. Separate them.
Separate it. Now that's the key thing there. So we have a receive antenna and a transmit antenna, right? The key thing is there, to get the same isolation of separating those two frequencies out that these duplexers do for us. When you do it with antennas, you need about minimum, at least for a 50-watt ham repeater, you need at least about 85 feet of vertical separation between the two antennas, and a lot of times a substantial amount of horizontal. It depends upon the size of the tower and all kinds of other factors. We have operated the 9.7 when we had a problem years ago in that mode where we had the receive antenna at the top of the tower, the one we were using for duplex operation, and we put a transmit antenna down low, and we had enough separation. I think we had about 120 feet, maybe a little less than that, and that allowed us to operate the repeater when our duplexers were sent away to be retuned, recalibrated. The problem with that is that's two antennas, two feed lines, and to get that same isolation or separation between those two frequencies, the send and the receive, or the transmit and the receive, is a challenge. So you can see how these are really wonderful things to have and allow you to accomplish that. Now, if tower sites are plentiful and you have lots of money, I'd go with the separate antennas because you were licensed in Chicago, weren't you, or no? Oh, you weren't. Shoot. In Chicago, there's one of the big ham clubs is the Chicago FM Club. They have a repeater. Well, I'm going to say a transmitter on top the John Hancock, which is one of the tallest buildings in the world. Guess what? It's just a transmit antenna. The receive antennas, they used to have about 3 or 4 of them, I'm sure this has all changed, spread throughout the Chicagoland area were the receivers. So the receivers were miles away from the transmitter. But they had this big honking transmitted signal coming off the John Hancock, about the 4th or 5th tallest building in the world now. This big transmitted signal going everywhere. I mean, I could work it well into Wisconsin and well into Indiana, and it was incredible. It was this frequency, by the way, was 146.76 back then. I don't know if it's changed. But it was run by the Chicago FM Club. But they had these receiver sites, notice I said sites, throughout Chicagoland and the suburbs and everywhere. And what they did is, those receivers were on the receive frequency, which was 146.160. They brought that receive signal in and they sent it over, now I'm sure internet, but back then it was over phone lines, back to the transmitter. That's how they coupled. Very expensive. They paid a huge amounts of rent, but they had the money, and they had the sites. They had the tower sites available, and it was really interesting. And there was an added piece of equipment there, which actually I have sitting in my garage. Actually, I think I just got rid of it, but it's called a voting selector, and it's a piece of equipment that actually listens to all these different receive signals and grabs the one that's strongest. It measures it, grabs it, and says, okay, you're the strongest, I'm going to grab you. So if you're driving around Chicagoland and you're up in McHenry, there's a receive site up there that you're solid into. It's grabbing it and sending it downtown to the transmitter on top of the Hancock. Well, you keep driving, let's say you come around now to the south side of Chicago, there's a receive site there, grabs you, it disconnects that one up in the northwest side in McHenry, and now connects you to the south side. So it's automatic. It's a kind of like how cell operates, actually, to some extent. So anyway, that would be an ideal situation if you had that kind of capabilities. But you can see the cost that saves you on everything else by having duplexers and what you can do with them. They're kind of a magical piece of device, but they're not that sophisticated. The tuning of them and setup is a little involved. We sent ours away to the factory to have them retuned for the 9.7. Paul Racine has tuned some up for me, for my repeater. Todd Bird down in Rapid River, but you have to have the right equipment to be able to do that. It's not easy.
How is this the same or different from when I cross-band in my dual band thing?
You're doing basically the same kind of thing, aren't you? Mm-hmm. You're still acquiring full duplex. And what she's talking about is, everybody here use crossband? I know Mark has, I know you have, Mecca, you know.
I'd never bother.
But it's kind of a neat cheater. How long it took somebody to come up with this idea, huh? But basically, let's say you're on your HT, you're out on the UP 200 sled dog trail. You're transmitting on one frequency to your mobile radio. It automatically is receiving it and retransmitting it on another frequency, and then that frequency is going to the repeater or wherever else you want it to. But here's the key thing, though, about cross-banding. That's the word there. You're not talking about a 600 kilohertz spread or a megahertz spread. You're talking about hundreds. You're completely different bands.
That's right.
So you can get away with murder, meaning those two don't interfere with each other, right? Mm-hmm. But it's very similar configuration. So,
Al, so it's running on HF. If you're running split, it's kind of the same thing.
yes, except for there's no repeater involved,
Right.
with the other operator.
Right.
And I don't think does everybody here operate HF or do some HF, pretty much?
No.
So you know what split operation
Right,
is?
No.
That, you know, and you hear the DXers do that a lot.
Right.
You know, they say I'm transmitting at 14.280, listening at 14.250. You know, so that kind of a thing. Again, you're separating the two, but in that case, it's really you just matching up.
Right.
Split operation. It's
Right.
not quite full duplex repeater operation. It is amazing. The other thing is that similar to this in nature, and by the way, again, the principle, and again, the handout really does a better job, and I'm going to give that to you right now because we can ask questions off that. But the key thing about these duplexers is they are tunable in that it's grabbing the incoming receive signal and basically matching it through these tuned elements, these cavities, and bringing it along, but being tuned to reject and ignore the transmit frequency. That's basically what they're doing. So it's called, a lot of times you'll hear the term band pass, band reject filters. Basically it's the same thing, duplexers. Band pass, band reject. Excuse me. In our case, we're doing it on a very specific frequency and spread. When you talk about band pass, you can take entire segments of bands and do the same thing. The next thing this leads us into, which is becoming more and more popular, called combiners. Combiners is where you have a single antenna and you're putting multiple transmitters or transceivers. And by the way, that's something I always forget to mention. When I say to you transmitter versus receiver, and then I say transceiver, somebody tell me what a transceiver is.
That's our radio
Both.
terminator.
Oh,
It does both,
and
right?
receive.
What's the key thing that allows that transceiver to work?
must be a duplexer.
No,
Well,
because you're not doing both at the same time. But there's one little component in there that is critical, and that transceiver that makes it work, which we don't even think about every day. There's something called a transmit-receive relay. And they're all solid state now. They used to be mechanical, where you key the microphone, you hear a click, right?
Yeah, I remember that.
Yeah. And what it is when you go to transmit on your mobile radio, you have to block and disable that receiver. Otherwise, you'd fry it right out. You'd burn it out. Because you're transmitting 50 watts out of your mobile radio. If your receiver was coupled to the antenna at the same time, boom, you burn it right out in a second. So there's a little thing in there called a transmit receive relay. You'll see it abbreviated TR relay. That makes your radio a transceiver. It toggles it back and forth. Otherwise, you'd burn your receiver out.
That's so you could have it in one radio. Otherwise, the old days, you had a separate transmitter, separate receiver for your ham radio,
HF especially.
and HF.
Most of the HF rigs in the 60s and 70s were receiver and transmitter separate. And you had to really watch that because you had to have a connection between the two to mute the receiver, otherwise you did some damage. So that's critical for a transceiver to work. Well, combiner is another principle based on duplexers, really, or cavities, where you're putting multiple signals into the same antenna from different bands, different frequencies all over the place. Combiners are becoming more and more widely in use and more common. Can anybody tell me why?
price.
Price? That's the key. We're running out of tower space and antennas. People are fighting putting towers up. So now I put an antenna up and I say, okay, we're going to put into this one antenna, we're going to put range paging, VHF paging, we're going to put EMS for Marquette General Hospital.